Okay, and here we have a class man and a derived class hombre from man, and you can see that hombre will inherit all the members of the man class. So we're going to speak class and we're going to speak string class, but it has an overriding method here, um, that overrides this function. But this down here, this code shows that, okay, we got Henry is a man and Lefty is an hombre, and Henry.speak, it's a beautiful morning, and then we got Lefty.speak, which inherits that same function. Okay, goddamn IntelliSense is fucking up again. God damn it. Son of a bitch. Okay, and anyway, this shows you that, you know, okay, you can see what the output, of this is. Now, what's interesting is that just like I say here, I tried calling the lefty speak method, but like I said a couple of months ago, it's overridden, so call the function. Well, the thing is, it's not really overridden. It's overriding the overloaded constructor. I mean, the overloaded method. I mean, that's not a constructor. It's overriding the overloaded method, but it's not overriding the original method. But apparently, that's how it works. If you override one method, you override both. Even if I had like 6 speak methods, and man, just redefining one of them, would override all of them apparently. So, um, and just to test that theory, I created a barf function in the man, and it inherits that okay, but I'm not overriding it or or an overloaded method of it. So, but it does show you, yeah, you can override methods, but if you do, you lose all of them. So you lose, any overloaded function definitions that are part of the base class that you're deriving from. So, you got to use that carefully. Okay, and this here, is talking about, the fact that you can take a class and pass it into a function, and that's what we do here. Um, we're passing firstly, Henry, which we defined before, into this function. Which I guess I can go use this window to show you where that is. Okay, here are these functions here, by the way. Okay, so anyway, my function, we're passing Henry in, and the function's accepting a object of class man by reference. So, basically that's calling it like so. Man, assholes. At any rate, it's passing it in, and that just that function just does the speak function, and this function, it's able to do it with a dot operator because it's passed in by reference. Here, it's passed in as a pointer, my function pointer. So, and that's what we do here. We, create a pointer of class man, and then we instantiate it. here in this case, because I could have actually pointed this at Henry if I wanted to, but here we're actually creating a new object of class of type man in the heap. So this pointer is pointing to that man in the heap, but you don't have to do this. I could, like I said, just say class pointer equals Henry, or the address of Henry. Well, like this fucking IntelliSense is just on the fritz. Anyway, I'm passing it, I can set it to Henry just like I did, or I can create a new object on the heap. But either way, it'll either way it'll work. So don't let this confuse you. But then we're passing that pointer in, into this particular function here. It's got to be of class man, and it's basically going my object dot speak equals assholes. Now that's a a class member pointer, or class pointer version of the dot operator, so you can access members of a function. So and you just have to type point or dot, and it'll do the arrow for you. You don't have to type the stupid arrow. So just to give you but of course it's not going to do it because fucking IntelliSense is fucking on the fritz. Goddamn Microsoft. Okay, well, I got lucky and it did do it. But at any rate, that's just all it's showing you, is that you can pass, objects into functions, and there's two ways of doing it. One's by reference and the other's by pointer. By pointer, the notation's a little different, but the outcome is still the same. Okay, after rebooting IntelliSense for like the 4th time, we're passing in pointers to it, alright, but just like this note says, actually we never call my function 2, but the fact of the matter is, if you wanted to, you can't modify, you can't run any of its methods, because we declared it a constant here. So and it's a reference. So since it's a reference and a constant, we can't run any of its methods, because they might modify the members, even though my object dot speak doesn't modify it. And like I said, like Henry, we could have passed him into my function 2, and it wouldn't have a problem. Like, for example, I can go my function 2 and pass them in Henry. Stupid Microsoft. And since it's void, I can just call it like that. And basically that would just display his age, like this function would imply. But you can't call any of its methods or or set any of its members or anything like that, because you're passing in by constant. So you just look at its data. You can't. So that means if I had getter methods in there, I couldn't call those either. When you pass it in by constant, and normally you would when you're dealing with objects. Normally you would have getter methods, and this implies that you can't run those getter methods. Because a speak wouldn't do anything different than a getter method. I mean, that speak function, if you recall, just outputs a cout message. I mean, it doesn't really do anything. It's not modifying anything. But like I said, so using constants with an object, an object reference doesn't make much sense, because normally you would have getter and setter methods, so you really couldn't do anything with the object if you passed it in like that. You couldn't view any member data because there wouldn't be any public member data. And you can't execute any of the functions like the getter and setter methods, so what use is it? So that's kind of pointless. With pointers, like I said, you can, make the pointer constant or the data it points to constant. So that would be kind of like the same thing if you're passing it in an object. You wouldn't be able to access any of its methods ostensibly, although I still kind of wonder if that's really true or not, or if it's just some bizarre thing I'm seeing here. But cause maybe with pointers that doesn't apply. I don't know, because I don't have a pointer version of it. I'd have to create one and see. But other than that, we'll probably get back to that, because I know that's something that's definitely that Chili does all the damn time. So we'll see if there's an issue with that. But this, I don't know what's going on, but I know I cannot do this. It won't accept it. But I can't even not only do this method, but I mean, I can't do the basic version of it either. Damn it, IntelliSense is already fucked up again. Yeah, it's already fucked up again. Already. It's after rebooting it for like the 4th or 5th fucking time. Unfucking believable. Alright, there's a goddamn update available. I'm gonna apply that motherfucker right when I'm done with the final video here. God damn it. At any rate, I'm just going to leave this topic alone until later, so we'll get back into that later, because I don't think it's as restrictive as is implied by this. Because again, you wouldn't be able to do anything with a normal class, properly defined class. You'd be just fucked. I mean, there's just nothing you could see or do. Since you couldn't, definitely not call setter methods, but not use getter methods either. That really doesn't make any sense. Okay, and this, the reason we have constructor and destructor in there is because I pressed the tab key when I was typing in the class name. So if you type class, then press tab, it creates that whole class structure for you. So that's why that's there, for no other reason. But really, the lesson involves just this status and two functions here, eat and rot, which are defined down here, eat and rot. So you can see what it does. Now what's interesting about these member functions is that they call this external function right here. And this external function, accepts a, so this can be called by technically any object of cheese class. Um, not just any object, it's got to be a cheese class object, you know. So, but these member functions of the cheese class are calling that object, you know, that function, and passing it this pointer. So that's a pointer to the current object. So, but it's a pointer to the object, not to this particular function per se, but to this object. And you can, and again, if IntelliSense wasn't fucked up, I would show you that using the this pointer, you know, you can actually access member functions and member variables using it. Let's see how fucked up IntelliSense is. Yep, it's pretty fucking fucked up. So, anyway, but anyway, you can, you know, use it, you know, with the dot operators, you know, to like call rot, for example. I could do that. But I wouldn't need to, but I could, you know, because I mean, I could just call the rot function directly from this in theory. But again, with IntelliSense on the fritz, who the fuck knows? But anyway, the point is that it calls this, you know, both of these call this function, you know, which is one more cheese gone, okay, and passes at this pointer again. Another really great example of how useful this shit is, typed straight from a book. But at any rate, what this deals with is it has a global variable defined here. Alternatively, it could be defined in this function as a static, or as part of this class as a static variable. But that's basically keeps track of how many cheeses you have, and every time it's called, it decrements that cheese and then updates, you know, the block dot status gone. So, and this is an example of how you use the this operator, sort of, you know, because I could have had this dot status, you know, but it won't let me do it. Since that's just a string. But again, it's not going to let me do it because it's stupid. Not going to type the fucking pointer thing directly. So, you know, I could have done that, you know, is what I'm trying to say. But, you know, IntelliSense on the fritz. Ah, shit. God damn it. But anyway, you know, that's kind of the point of the lesson, is that you can call an external function, you know, from a member function, and also deal with, you know, a global variable. But you don't have to. But I mean, that's the whole point. This actually keeps track of it for multiple instances of that cheese class. So, see, we have cheese Oswego, cheese Munster, and we create pointers for them, and they're creating instances of that out in the heap. For whatever reason, again, you don't have to do this. You could create them in the stack, but it's creating them out in the heap, which is just more of a common way of doing it. Then we're setting cheese count. It's a global variable to 2. But then we're doing Oswego.status, you know, 1 left, Munster.status, you know, 1 left, you know, because status is not a global variable, it's a local variable. See out cheese count. So we're doing a cheese count function, you know, it's what we're calling. Alright, and then we're looking at the status of it on both cheeses. Here's the cheese class. There's the status variable. It's really just looking at a member function here. And then that's pretty much it. So, not very exciting. So you can see the counts 2. Cheese count equals 2. Okay, so we're doing a cheese count after setting its status. Cheese count 2, that's what happens here. Okay, then we call the Oswego.status. It says 1 left, 1 left. Okay, then we're doing Oswego eat and a Munster rot in succession, and then we do a cheese count here that shows that the rot and the eat function. Here's the eat, yummy, and puts a message, and then here this puts a message, cheese has gone off. Yuck. So, but since it calls the one more cheese gone function, that deducts from the cheese and updates the status and the member variable, which it can do that because that's apparently public, which it shouldn't be. Normally do that through a setter method, but anyway, but then we do a cheese count. Now it's 0, so, and the status is gone for each because we, because that function has that net effect, of setting the cheese to gone. But again, this is a silly frickin' program. Because if you set the cheese count to like 56, okay, it's gonna update the stats. There needs to be some if-then statements and a bunch of other shit, but you get the picture. I mean, that's the whole point, though, is that it's calling. You're able to call outside functions, within a class function or from a class function, pass it to this pointer, okay, and that allows it to operate, on a given instance of the class that calls it. Because again, both the Munster and the Oswego instances, call that external function, which there's one copy of in memory, and then there's one copy of our, our global variable, that it updates. So, but again, that's one way of going about it and dealing with these issues. So, anyway, time to update the fucking program here.